Linear equations. In the past, we saw separable differential equation of the form dy dx equals f of x times g of y. And so y prime is a product of two functions, one is x and one is y. We now look at the first order linear equations of the form y prime plus p of x times y equals q of x, where p and q are function of x. Usually, this is not separable. For example, solve the differential equation x squared y prime plus 2xy equals 5. If we isolate y prime, we see that it is 5 minus 2xy over x squared. We simplify this, but it is not separable because we can't express this as a product of a function of x and another function of y. But observe that x squared y prime plus 2xy is the derivative of x squared y. Notice that the derivative of x squared y with respect to x using the product rule implicitly is 2xy plus x squared y prime. And so the derivative of x squared y has to be 5. But if the derivative is 5, then x squared y is 5x plus c. And so y is 5x plus c over x squared. And we found the solution. How do we know that this is the correct solution? We checked it. We can rewrite y as 5 over x plus c over x squared, which is 5x to the negative 1 plus cx to the negative 2. So the derivative is y prime equals negative 5 over x squared minus 2c over x cubed. We then multiply both sides of the equation by x squared to get x squared y prime equals negative 5 minus 2c over x. But c is x squared y minus 5x. So we replace c with x squared y minus 5x, and then we simplify. We get x squared y prime equals negative 5 minus 2xy plus 10, which is x squared y prime plus 2xy equals 5, which is the differential equation that we started out with. And so we know that this is the correct solution. This is the basic idea behind the solution of the first order linear differential equation of the form y prime plus pxy equals q of x. In order to solve the linear equation, we need the left-hand side to be the derivative of something. If it is not, we have to manipulate it so that it is the derivative of something. We do that by multiplying the linear equation with an integrating factor, I of x. We first start with the linear equation. We then multiplying both sides of the equation by the integrating factor I of x to get I of x y prime plus I of x pxy equals I of x times q of x. And we need the product I of x px to be I prime of x, so that the left-hand side is the derivative of something, and that something is I of x times y. And so, since the left-hand side is the derivative of I of x times y, I of xy must be the integral of the right-hand side, the integral of I of x, q of x, dx. Note that if we take the derivative of I of xy, we end up with ix qx. Next, we isolate y. Y is 1 over I of x times the integral of I of x, q of x, dx. If we can integrate this, then we obtain the solution. So what is this integrating factor I of x? Since I prime of x is the product of I of x and p of x, which is what we need, or di dx equals ix times px. This is separable. di over I equals px dx, and then we integrate both sides of the equation. The antiderivative of 1 over I with respect to I is ln of I. We keep the right-hand side as it is. We then e both sides of the equation to get I equals e raised to the integral of p of x dx, maybe with a plus or minus. And this is the integrating factor. And so the general solution of the linear equation y prime plus pxy equals qx is y equals 1 over ix times the integral of I of x times q of x dx, where I of x is the integrating factor and it is e to the integral of p of x dx. Let's check to see if it works. For example, solve the linear equation y prime plus 2 over x times y equals 5 over x squared. This is of the form y prime plus pxy equals qx, where p of x is 2 over x and q of x is 5 over x squared. The integrating factor is I of x equals e to the integral of p of x, but p of x is 2 over x dx. We integrated and simplified to get x squared at the integrating factor. We then multiplying this integrating factor to the linear differential equation that we started out with. We get x squared y prime plus 2xy equals 5, which is the first order linear equation that we solved earlier.